So in the thermodynamics, whenever we talk about thermodynamics, first of all the basic introduction you need to know what is system, what is surrounding, process, different type of processes. We'll go ahead. First of all, system can be wherever we confine our attention. You are writing by pen paper, that is your system. You are doing typing in the computer, that is your system. So wherever you do your some job, that is the system. And what job you are doing, that is the process. That is very close. Okay, one is system and another is process. System is where you are doing the job, and process is what job you are doing. That is the process. System can be three types: open, closed, and isolated system. Open system where the energy and the mass both are exchanged with the surrounding. For example, boiling water into beaker without any lid, because the vapor goes out, so mass transfer is happening. You are applying heat, so heat transfer is happening. So these two processes, one is mass transfer, other one is heat transfer. This heat transfer and mass transfer is very important aspects in chemical engineering as well as mechanical engineering, because these are the basic operations that they are studying. What are the operations they study? Heat transfer, mass transfer, and fluid dynamics. These are the basic things they are studying, mechanical engineering and chemical engineering. Okay, so this is the thing. So mass transfer is happening, heat transfer is happening in open system, and closed system means there is a lid. It is closed. It is closed. So that means the vapor cannot go out, or any matter cannot go out, or neither it can come in. There is no mass transfer operation happening, but heat transfer operation is happening. That is called closed system. For example, the same boiling water into a beaker with a lid, tightly fitted lid, where vapor cannot escape. Okay, that is closed system. Third one is called isolated system, where neither mass nor heat energy can be exchanged. For example, thermoflask, the thermos bottle, where the heat and the hot water is kept hot and cold water is kept cold. So that is your very close example of isolated system. Though it is not very accurate, but still very close process. Next is boundary. System and surrounding, in between the level is called boundary, and beyond this boundary what you have is called surrounding. There is a system enclosed by a boundary. Beyond the boundary, whatever you have, that is surrounding. And we just always observe whether any heat transfer operation going on between the system and surrounding, or mass transfer operation happening in the system and surrounding or not. Accordingly, we classify open system, closed system, isolated system. Next we have this is open system. Well, so mass and energy both are exchanged, that is open system. Closed system, here mass no exchange, it is written no, so mass exchange is not occurring, but energy exchange is occurring, that is closed system. And isolated system, neither energy nor mass, nothing can transfer between the system and the surrounding, that is called isolated system. Properties. Some properties are called intensive property, those who are independent of mass or amount or quantity. Some are called extensive property, those who are mass dependent or amount dependent. Some example where mass it does not depend on amount is surface tension, viscosity, refractive index. This property does not depend on the amount, how much bulk you are taking. If you take a 1 glass full of water, obviously throughout the this surface tension, if you analyze in the glass full of water, and if you take a bucket full of water, surface tension will be same water you are taking, the surface tension will be same. It does not depend on quantity. But if you take volume, okay, 1 glass full volume is small, 1 bucket full volume is large, so that means the amount or volume dependent parameter. Volume is a amount dependent parameter, so that is called extensive property. Intensive property independent of mass, and extensive property mass dependent, mass or amount dependent. Some properties are called specific property, per unit mass, per gram, this type of unit whenever you are using, said that heat capacity per unit mass, that is called specific heat capacity. Resistance per unit some length, that is called specific resistance. So specific means per unit quantity. Whenever it is specified, that is called specific. Okay. Optical rotation, specific rotation. Heat capacity, specific heat capacity, molar heat capacity. It depends on quantity, that's why. Okay. Now, state, equilibrium and process. State, what is state? There are some states we know, solid, liquid, gas, plasma and Bose-Einstein condensate. These 5 are common. There can be others also theoretically possible, practically not found states. And phases, there are numerous phases possible. When you are melting some solid, there can be some semi-solid condition. That you cannot call it a state, but it's a phase. Okay. Now, same solid material can have multiple allotropes. Diamond, graphite, fullerene, these are all crystalline carbon. They are all solids, same state, but they are all different morphological property. They have all different type of property. Allotropic behavior is different. So in that case, we call it they are in the different phases. Alpha sulfur, beta sulfur, monoclinic, rhombic sulfur. So they are all solid, both are solid, but physical property, some of the chemical property also different. Activity, chemical property, activity is chemical property, whether it is reactive or not. So there is different. So accordingly, call it a, these two things are in two different phases, not state. Same state, different phases. Now equilibrium, whenever forward and backward some reaction going on, it will be said to be in equilibrium. Now there is another one called steady state. Okay, steady state. What is steady state? Steady state means the same rate, some material is coming in and the same amount of material is going out. Maybe from a water tank, water is getting filled in and water is getting going out by some other that outlet. So in that case, the rate of filling of the tank and rate of that outlet, both are becoming equal. In that case, we call it the system is in a steady state condition.
So mass will be constant now?
Yes, everything will be constant, but there is not the same water, not the same material, similar, not same. There water is flowing out. Suppose you take a swimming pool. Swimming pool, water is getting filled in and water is going out always. Just to keep the steady, and it is for hygienic, to maintain hygiene, because so many people are going in, doing the swimming. So they have lot of bacteria into their body. They have a lot of dirt into their body that is going washed into the water. So water must be renewed. But if you cannot renew the whole water at a stage, because the quantity of water is enormous. So in that case, what people are doing, continuously water is getting filled in and water is going out from the bottom. There is some pockets at the bottom. There is a outlet. So water is constantly going out and water is also coming in. So that way water is getting refilled and it is getting renewed. So it is at least maintaining better hygiene. It is not stagnant water, it is flowing water. That's why it is not that toxic. The water will be suitable for use. So that is called steady state condition. The river water is coming in from the mountain and is going to the ocean, continuous fashion. That is a steady state. Just ignore the high tide, low tide. Otherwise, it is constantly, it is steady state condition. So now, next topic, some different type of processes: isobaric, isothermal, isochoric, isentropic, different type of processes. So isobaric means throughout the process the pressure is constant. Isothermal, temperature not constant. Isochoric, volume constant. Isoentropic, entropy constant. Iso means same. So isobaric, isothermal, isochoric, isenthalpic, these are all called processes, and these processes are at a particular parameter remaining constant. Other parameter may vary, but one parameter remaining constant. There is another, apart from all this, whatever mentioned here, apart from this, there is another one that is called adiabatic process. Adiabatic process where the system surrounding heat exchange is burned, not allowed. So, if the system surrounding heat exchange is not occurring, that process is called adiabatic process. Now, this adiabatic process can be your what you are calling different processes. Adiabatic process also can be your isolated, but all isolated process cannot be always adiabatic. Not same actually. Adiabatic process can be isolated. Okay, but isolated process obviously will be adiabatic. That is the difference. See, what is the meaning difference? In one case, I am telling it is separated from the surrounding. It is totally isolated. It is sealed. So it must be adiabatic. But adiabatic does not mean it's sealed that way. There is a slight difference. Now tell me what you are telling. Internal energy may change. Internal energy may change, but it cannot. Inside the some work may be done. Work is done, but no, not from any external energy or external heat. But by expense of its own internal energy, some work may be done. That is happening inside. That is also totally inside the system, not anything with the surrounding. Okay. Now, final state and initial state. Suppose some expansion process going on. This is the system. Here is the lead. Here is the lead. Now, you pull the lead or push the lead from here to here. Pull the lead from here to here or push the lead from here to here. We are actually doing some change. Now, if you suddenly push it from this position to this position, pressure will be enormously changed, lot of pressure will be changed, volume will be changed, pressure will be changed, temperature also may vary, supposed to be, because compression producing heat, it will increase because compression gives heat and expansion gives cooling. That is our common experience. And thermodynamics is not just a theory, it is our common experience, human experience over a long period of time. That is thermodynamics. Common experience over a long period of time. It is not that it is discovered by some scientist. Just like we got lot of laws discovered by some scientist, Newton's law, etc., Einstein's equation, that is discovered by some scientist. But this is our experience over a period, long period of time. Thousands of years people are experiencing this thermodynamics. Maybe thermodynamics name was not given, but people experience the problem and solutions. From the thermodynamics only, people are using this problem and solution both are defined from a long period of back, long back. Achha, by the way, so here the pressure is increased, so the volume is decreased. So here volume V1 here, volume here. So this is the axis. So this is the volume axis. So V1 to V2, when you come, that means you are compressing the system. V1 to V2. So in that case, pressure will be changed from P1 to P2, state 1 to state 2. Now this can be done in two different ways: sudden change or very gradual change. If you do it in a sudden fashion, suddenly you compress the lead, then what will happen? Then the heat generated cannot be dissipated to the surrounding, and suddenly it will raise the temperature of the system itself, because suddenly you are pressed. So whatever heat generated, that could not be dissipated, it will be contained in the cylinder itself. Another way you can do it, you just take the cylinder and on the top of the cylinder you add, theoretically, not practically, one granule of sand at a time. Just theoretically you think over, some robotic hand is adding one granule of sand at a time. So you are actually adding more and more load, though it is infinitesimally small. So compression is going on, and whatever heat generated, that heat will be dissipated always, because it is getting sufficient time. Slowly the compression is happening. So whatever heat generated, that heat must be dissipated to the surrounding in a nice manner. No problem. So that's why the temperature rise we could not feel. If the cylinder is not insulated, if it is a conducting cylinder, metallic cylinder suppose, because that much of pressure if you have to withstand, so normally it is a metallic cylinder. So in the metallic cylinder you are applying pressure, so heat is generated, but as it is a conducting material, the heat is immediately getting dissipated and you cannot understand any temperature change. Then the process will be isothermal also. Because always the heat is getting dissipated, so temperature is not changing. So isothermal. Practical scenario I am telling for how we can get isothermal, how we can make isobaric process. This way we are making isothermal process. We are doing it. How? Adding one by one sand. Practical way. You are just on the piston of the cylinder, you are adding one by one sand. So one sand is so small, tiny particle, its weight is so small, the piston is going so minute way, you cannot practically feel it. But after certain period of time, maybe after 2 hours, you will find sufficient shift. Already shifted a lot. Heat also generated, but you cannot find the heat. It is already gone. Then is isothermal.
But sir, it's not ideal.
No.
For a certain time it will be changed.
No, it is not ideal.
Not ideal.
So reversible, theoretically, reversible is ideal. Ideal is reversible. Ideal is reversible, reversible is ideal. That is true. So, this reversible process practically cannot be done. It's a theoretical concept only. Practically, we can do this very close to this ideal. Not very ideal, but very close to ideal. Just like thermoflask is an example I told you, but it's not very ideal. There may be leakage. Practically, there can be leakage. But here also, there can be some heat generated inside. May not be very ideal situation for isothermal, but it will be very close to ideality. Okay. Now you are removing the sand particle again one by one. Piston is going up, but the heat is collected from the surrounding, so temperature remaining constant. Now think of it. This cylinder is made of some very non-conducting material, insulating material, totally sealed. So in that case, if you do this process, temperature must rise or temperature must fall. Then it is not isothermal. Okay. Now, volume remaining constant. How possible? If you do any expansion job, contraction, then volume must be constant, cannot be constant, right? It will be changed always. But you can change to other two parameters, pressure and temperature, then volume may be constant. Pressure you are decreasing, temperature you are increasing. They are compensating each other. So volume may remain constant. Possible. Theoretically it is possible. So this is called isobaric process. Isobaric, pressure remaining constant. You are not changing any pressure. You are doing it is in atmospheric pressure conditions. So pressure you are not varying. So isobaric is possible. Now, so isobaric, isothermal condition I told you. This process, if you do in a minute and slow stage, so that always thermal equilibrium is maintained with the surrounding, then it is called reversible process. Reversible process. কিছু শুনেছো? তুমি কনস্ট্যান্ট গল্প করছিলে, তাই বলছি। পেছন দিকে তাকিয়ে লাভ নেই, তোমাকে বলছি। কনস্ট্যান্ট কথা বলছিলে, তুমি না, তোমার পেছনে। হ্যাঁ, আমি দেখছি না মনে করছো না? প্রথম দিকে কিছু শোনোনি, পরের দিকে শুনছো। আর এগুলো কিছু শোনোনি, সব বাদ দিয়ে গেছে। আমি সবাইকে দেখছি, সেইভাবে ভাবো। So, what is this reversible? Reversible means minute stages, each and every step, the equilibrium is maintained with the system and the surrounding. Equilibrium is maintained always throughout the process. যতক্ষণ প্রসেসটা হচ্ছে, so far it is happening from this point to this point, or this point to this point 1 to point 2. So this compression happening very very minute slow stages. In that case, the pathway will be like this. It will be like this. It's a very gradual change. That's why pathway will be this exponential type. And if you suddenly do the changes, then it will be from this line. It is linear from here to here. Suddenly you are changing from V1 volume to V2 volume. That means compression. Then pressure will be suddenly raised from this point to this point. This sudden change if you do, it is called irreversible. If you do the sudden change, then system will not get time to maintain equilibrium with the surrounding. So equilibrium is the most important point here. That's why this heading is equilibrium. Equilibrium is very important here. Without the equilibrium, it will be called irreversible. And whenever the equilibrium is always maintained throughout the process with the system surrounding equilibrium, what type of equilibrium? Pressure temperature equilibrium. If it is maintained with the system surrounding, then it is called reversible. Reversible is gradual, slow, minute step, and irreversible, sudden change. Now one example. You have got a gas cylinder at home. There is a leakage at the valve at the top of the gas cylinder, and throughout the night, overnight, the gas got leaked out, and in the morning you found the cylinder is empty. Is it reversible or irreversible? This process, what happened here, reversible or irreversible? Irreversible. But still, it is with the very slow and minute stage. Though it was very slow and minute, but still it is irreversible. That way you have to think that it was no equilibrium was not maintained. Though it was very slow and minute stage, but equilibrium was not maintained, so it is irreversible. People may make mistake here because it is very slow, minutely the gas is going out. So you can think that it will be reversible, but it cannot reverse back. Think about that. One gas is going out, can it come in? So how can be reversible? Reverse means it can go back. It is not going back. Gas is not going back into the cylinder, never. So in that case, it is irreversible. Okay. So if you do the sudden changes here, then it is following a linear path. And if it is going in a by gradual change that way, the earlier page, see, this is reversible way it is happening. So in that case, it is following this path. Otherwise, it will follow this type of path, linear path. Because suddenly the change is happening. After that, whatever expansion that is. First, you are changing from this volume to this volume, initial to final volume. VI means volume initial, volume final. So this much is the volume change. So pressure will be automatically raised from this to this, initial to final. Isochoric, the plot will be like this. Isothermal, plot will be like this. Parallel to x-axis. Temperature is not changing, that's why temperature axis if you follow. So it is parallel to x-axis. Here volume is not changing, that's why the v-axis it is not changing, it is parallel to y-axis. So reversible, irreversible already I have discussed. You just have a look, go through. So cyclic process means starting from a point, if you come back to the same point, that is called cyclic process. Now, here to Venacity you are going and then coming back to the same point. You are going to Venacity from here and coming back by a different path and coming back to here. According to science, you have not done any work. Though you are very much exhausted, but still you have not done any work because your displacement is zero. Right? Now adiabatic process, a process that has no heat transfer into or out of the system, it can be considered to be perfectly insulated. Adiabatic means insulated because there should not be any type of leakage. So one example I can tell you, air is a very poor conductor of heat. So air parcel, if you imagine there is air parcel without any boundary, imaginary boundary, practically there is no boundary, this air parcel can go up and down, though you cannot see it because it is invisible. Air is not visible, air you cannot see, but this parcel is going up and down. That's why vertical circulation of air is happening. Air is doing up and down circulation, water is doing up and down circulation. That is not visible, but it has got a lot of impact into our life. Okay, it has got a lot of impact into our life. One example, you have a pond, temperature is dropping. In the winter season, the upper portion of the pond is frozen. It can happen, like Changu Lake, on the top of the lake is frozen. But the bottom of this ice, still water there, and aquatic animals are all surviving without any problem. Okay, so why it is happening? That is called stratification of lake. Stratification. Circulation was stopped. That's why upper portion frozen, but the bottom portion water is not freezing. It is still water, not frozen. Why it is happening? Suppose temperature is dropping below 4 degree. Whenever it drop, then circulation gets stopped because the highest density is at 4 degree. So whenever 3 degree, it is lighter, so it will be at the top. So 4 degree water is at the bottom, but 3 degree water will be at the top, 2 degree water will be at the top, and no further circulation will take place. So that way it will become 0 degree and the upper portion will be solidified, frozen. But below that ice, the water is still water, it is more liquid water, and the aquatic animal can survive. So it has got a lot of impact into life, that I'm telling you. So these aquatic animals are also living, so they have got life. So that life depends on this natural phenomena. And this process, this circulation, this adiabatic process, what is the importance? Why we do need to learn, that I am telling you. So everywhere in the natural phenomena is happening, and everywhere thermodynamics is happening without our knowledge sometimes. That's why you have to have some knowledge about thermodynamics. That practically we are using, that knowledge we are using. Achha, just think over, ocean full of water. Sometimes the ocean water is quite hot also in the summer season. So lot of heat there in the ocean. A ship is moving. Why it cannot collect heat from the water and run the ship itself without any motor oil? Think. Everywhere there is heat. Why can't you collect the heat and run your light fan? Why not? Tell me. Just think. That is same. Here also, you cannot collect the heat because the heat must flow. Then only you can use it.
The can collect, but after some time, it will be insane.
No, you can collect only when the higher temperature is higher than this. Your the heat engine or machine, whatever you have, it should have a lower temperature compared to the surrounding temperature. Then only you can collect it. Otherwise, you cannot collect it. Because current heat must flow. Just like until and unless current flows, you cannot utilize it. Lot of electricity is stored in the cloud, but you cannot use it. And when the electricity is falling in the form of thunder, then also you cannot use it because it is going into the ground. Whenever the current is flowing, that we can utilize. Static electricity you cannot use. The same way heat also, static heat also you cannot use. If the heat is flowing, then only you can use. And heat flowing whenever possible, when it will be possible, you have to have a high temperature and low temperature zone, and there will be heat flow. Heat flow, temperature variation, temperature gradient must be there. Just like electricity gradient should be there. That is called potential difference. That gradient is called potential difference. That potential difference should be there. So here also the potential difference should be there. If everywhere, that is natural phenomenon. This air current is also happening, up and down circulation is happening. So because of temperature fluctuation, otherwise the circulation will not occur.
Sir, as you can say that in the closed system, the energy will be changed. So the energy will be changed in form of
Exchanged,
heat only.
not changed, exchanged with surrounding, system surrounding
In form
exchange.
of heat only or
Normally heat is always getting dissipated. That is a very common one. It may be other also, light also. Heat, light, others also can be possible.
What is the difference between insulated and isolated?
Insulated means thermal barrier, specifically thermal barrier. But isolated means barrier for everything. Isolated means barrier for everything. And insulated means barrier for the heat barrier. It is a sort of non-conducting material you are covered. Sometimes it may be very close. See, throttling process, isentropic process. Isentropic process means the entropy is constant. That is isentropic process. Joule-Thomson experiment is an isentropic process. Isenthalpic process. There can be another one called isenthalpic process. Isoentropic means the entropy same. Iso in enthalpy change. Enthalpy means heat content change. Throttling process, where there are a lot of holes and through that hole, the nozzle, the gas is going out. That is a phenomenon. Separation of two different gases by this throttling process. The name is diffusion and effusion. You have heard about diffusion? Diffusion and effusion.
Thermodynamic process. At first, we need to know what is process. A process is nothing but a transformation from one state to another. But in thermodynamics, the transformation of a system from one equilibrium state to another is called a process. Now, what is thermodynamic process? When the thermodynamic system changes from one state to another, the operation is called a thermodynamic process. This process involves the change of conditions such as temperature, pressure, and volume. For example, consider a piston and cylinder arrangement in which 4 weights are placed on the piston. If 2 of the weights are removed, the piston rises, and that changes the state of the system. Let P1 and V1 be the initial values of pressure and specific volume before removing the weight, and P2, V2 are the corresponding values after the system has attained a new state. In this process, energy may be transferred from or into the system and can be done by or on the system. Types of thermodynamic process. The various types of thermodynamic processes are isothermal process, adiabatic process, isochoric process, isobaric process, and cyclic process. Now let's discuss these processes in brief. First one is isothermal process. Isothermal is derived from the Greek words isos and therm. Iso means equal. Thermal describes the heat of a system. So, isothermal means equal heat. This process is also known as constant temperature process. An isothermal process is defined as one in which the temperature of a system remains constant during the change from its initial to final state. For an isothermal process, dT is equal to 0. That means the initial and final temperature in this process is same. For example, the boiling of water at constant temperature. As shown in the above picture, the water is boiling, but this process occurs at the constant temperature. Second one is adiabatic process. The word adiabatic comes from the Greek word adiabatos. Adiabatos means impassible. This system can be considered to be perfectly insulated. So, adiabatic means occurring without loss or gain of heat. Adiabatic process is a no heat transfer process. An adiabatic process is defined as one in which there is no exchange of heat between the system and surrounding during the process. So, this process can be considered to be perfectly insulated and energy is transferred only as work. Since there is no heat added or lost in this system, then for adiabatic process, dQ is equal to 0. Here is a frictionless piston cylinder based enclosure. The piston moves up and down. That means expansion and compression takes place over here. But there is no heat exchange occurring between this system and surrounding, such as hot water in an ideal thermostat, because a thermostat does not allow for the heat transfer to take place through its walls. Next one is isochoric process. Isochoric is derived from the Greek words isos and chora. Iso means equal or constant, Choric means space or volume. So, isobaric means same space or volume. It is also called constant volume or isovolumetric or isometric process. An isobaric process is defined as the one in which the volume of the system remains constant during its change from initial to final state. For an isobaric process, initial volume is equal to final volume. So, dV is equal to 0. The boiling of water in a closed vessel is an example of isobaric process. In this process, the vessel is closed. That means the volume of the vessel remains the same. The volume is neither increasing nor decreasing. Isobaric process. The word isobaric is derived from the Greek words isos and baros. Iso means equal and baros means weight. So, isobaric means equal pressure or weight. An isobaric process is defined as one in which the pressure of the system remains constant during its change from the initial to final state.
Since the pressure is constant, initial pressure is equal to final pressure. So, for an isobaric process, dP is equal to 0.
For example, the volume of water in an open vessel. The boiling of water takes place at atmospheric pressure only. The pressure neither increases nor decreases. Last one is cyclic process. It is also known as constant pressure process. When a system returns to its original state after completing a series of changes, then it is said that a cycle is completed. This process is known as a cyclic process. For cyclic process, dE is equal to 0, dH is equal to 0. As in cyclic process, the initial and the final state is same. For cyclic process, the net change in internal energy is 0. The Carnot cycle is best example of cyclic process because inside the Carnot engine, fuel burns and converts the heat energy into mechanical work.
Now, there are two more important processes. One is reversible process and another one is irreversible process. What is reversible process? The process in which the system and surrounding can be restored to the initial state from the final state without producing any changes in the thermodynamic properties of the universe is called a reversible process. Melting of ice cream is a reversible process. Molten ice cream can be changed back to its solid form. Now, what is irreversible process? Let's see what is irreversible process. The process in which the system and surrounding cannot be restored to the initial state from the final state is called an irreversible process. A mixture of cement powder, sand and water is an example of irreversible process. This combination results in a hard solid and it cannot be reversed.